There's these two versions of the future you've probably heard. In the first, the robots come and take all our jobs. In the second, the robots extend human capability and we end up with superpowers to do jobs yet to be imagined. Who knows if either version will play out, but as designers, we prefer to think that we can all play a role in shaping what's to come. This robot fear usually involves self-learning computers, also known as machine learning. You may not see it, but it's technology you probably interact with every day.
Alexa, what
And
is
because it's kind of invisible, that makes it slippery to work with. Those of us who aren't computer scientists are left wondering, isn't there a way to just start playing with this stuff? A designer named Mike Mattis created a simple prototype that suggests there is. The brain, as he calls it, helps answer basic questions about machine learning, but he doesn't reveal everything about how it works. So we decided to retrace and rebuild his prototype to better understand it. Mike teaches the brain to recognize drawings and match them with emojis using a neural network, a machine learning approach that roughly mimics how our brains work. We don't come into the world knowing what a smile looks like. That's something we learn over time. And same goes for the neural net. The more smile variations it sees, the better it understands what smiles are. But how exactly does it see? Well, there's two possible ways: pixel investigation and path investigation. Pixel investigation consists of examining each pixel in a rasterized smile drawing. Path investigation, meanwhile, consists of examining the X and Y positions of every point drawn in a smile. Pixel or path data is then fed to the neural net in a common language of values between 0 and 1. What sorts of patterns does the neural net find in the smile data? They probably don't resemble features we recognize, so it's hard to say. Once it knows what a smile looks like, though, we can show it new drawings and probability takes over. So we took these building blocks of Mike's prototype and began putting them back together using a tool called Framer. We were lucky to find some things others had already built for the drawing and brain parts of our prototype, and made our own thing for the perception part. This all came together in a version of the brain that's pretty close to Mike's original. We're still not machine learning experts by any means, but here's what we learned. Trained algorithms can only complete fairly narrow tasks, so how you configure a neural network depends a lot on the data you want it to learn. Your trained machine is only going to be as good as the data you give it, which means you usually have to think pretty carefully about what you're teaching it. And finally, for now at least, people are still at the center of machine learning. Someone's got to decide what the computer should learn and how they should learn it. We've included links to our prototype's code and a how-to article below. This video is part of a larger series we're doing on machine learning, and we're interested to hear from others who are curious about its impact on design practice.